Hello. In this video, we will discuss the Pandas library. We use Pandas for anything that has to do with tables. Pandas is an easy-to-use, fast, flexible, and powerful open-source Python library for working with relational or labeled data. It aims to be the fundamental high-level building block for doing practical, real-world data analysis in Python by offering data structures and operations for manipulating tables. And like NumPy, a Pandas implementation is faster than the default Python ones. And it is a third-party module, which means it is not part, again, of our built-in libraries. It is a very big topic and it has so many features that we cannot tackle. And I suggest that you do further studying by reading the official documentation. Again, we will just focus some of the essential things when using Pandas. So first of all, we have two data structures in Pandas. It's series and data frame. These two give us many features that make it easy to do data analysis. So let's start with series. Series is a one-dimensional array-like object that has index and value just like NumPy and is capable of holding any data type. To create a series, we can input a list, NumPy array, and dictionary. So here are some code that showcases those. So we use pd.series to create a series, and we can input a list NumPy array. In this case, this is an array. You could also specify the index names for the series. Now we end up with this series. So row A contains negative 0.54 and so on and so forth. We can also create a series from a dictionary. So we have library 1 as our key, and then the value is NumPy, library 2 as our key, and then Pandas as the value, and library 3 as the key, and the value is matplotlib. So we plug that dictionary inside this pd.series function, and we end up with this series. If we want to access the library 2, we simply do indexing. So now we were able to access the content of that item, which is Pandas. As you can see, when creating a Pandas series, only the data first argument is mandatory here. The rest are optional. You can opt not to input the name or index. If you want to edit a series, it is very similar to how you do it with dictionaries. So we initialize our series here, and we override the value by using this code here. So now the new value of library 2 will be Pandas 2.0. Initially it is Pandas. And then for library 4, well, there is no library 4 here. So initially this is the series that we have, contains library 1 and 2, 1, 2, 3, NumPy, Pandas, Matplotlib, and then we have overridden this value. Now it's Pandas 2.0, initially it's Pandas, and we have added GeoPandas, library 4, and then we deleted library 4. You could delete it using .pop, so now it is gone. That's it for series. Now we'll proceed to data frame. Data frame is like a spreadsheet or a SQL table. It is basically a two-dimensional labeled data structure with columns of potentially different data types. To put it simply, data frame is a multi-column series object. It is generally the most commonly used Pandas object, and like series, data frame accepts many different kinds of input, such as dictionary of 1D, and the arrays, list, or series, 2D, NumPy, and the array, structured or record, and the array, a series, or another data frame. Here are some examples of creating data frames. So for the first column, which we will name 1, it contains the series 1, 2, 3, which has an index of A, B, C. And then for the second column, it's 1, 2, 3, 4. See that they have different shapes. So this one has a length of 3, this is 4. But we specify the index. So when we create the data frame, it knows that for the first column, it's going to be not a number or nothing for index D because it doesn't have that. Just like series, you can access the following attributes: index, values, and columns. So you use .index, .columns, and the values. You can also create a data frame using a list of dictionaries. So this is our list. It has 2 elements. This is the first dictionary, and then this is the second element or the second dictionary. So for the first element, which is row 1, you have the following: column A, B, C, D, and it contains 1, 2, 3, none. And then the same goes for row 2. You have 2, 2, 3, 4. You can also get the transpose of the result using the .t attribute. Now, how do we edit a data frame? Assigning a column that doesn't exist will create a new column. If it exists, the assigned value will override the old one, similar to series. So for example, initially it's just 1 and 2, right? If we do this, it will create a new column named 3, and it contains none. Now if you want to delete it, you use the del keyword. Now it's gone. If you want to override a specific cell, you can specify the row and the column. So we override it with this value, 9,000. Now it's 9,000 here. You can also the .drop method to delete values. So we start with this data frame and then we use drop. So we say that we want to drop C and A. Those are the different rows. So now it's gone. We only have B and D rows. Okay, now let's proceed to indexing. There are many ways to select and rearrange the data contained in a Pandas object. Some indexing options can be seen in the below table. As you can see, there are lots of ways to do it. But let's focus on just a few examples here. So series indexing works similar to a dictionary. We provide the key. So it's S here. We start with the series. If you want to access the element, again, you just provide the key. Now we access the value inside that. For your data frame, to slice and select only column 1, and you want to specify the rows. In this case, you want it from 0, sorry, it's 0 and 4. We do the following. So we say that we want to access column 1, that's the first. And then now for the rows, which is this one, we say we want to access A and D, which stands for rows 0 and 3. Sorry, this is 3. Yeah, that's 3, 0 and 3 because it's 0 index. So 0, 1, 2, 3. Now, if we want to access from row B to the last row, again, this is 3, you can do slicing. So we start here in index B or row B up until the last one, which is D, which we have specified here. In the above cell, you will notice that slicing with labels behave differently than normal Python slicing in that the endpoint is inclusive. So we include the D row here. For data frame label indexing on the rows, there is a special indexing field block which enables us to select a subset of the rows and the columns. From a data frame with NumPy-like notation plus access labels. It is a less verbose way to do the reindexing, but we typically use this. This is typically my preferred approach to access elements. So df.lock, and then I specify the rows and the columns. So it's just one column 1 here and rows A and C. If I want to access multiple rows and columns, this is what I do. I want to access A and C rows and then 1 and 2 columns. That's it. Filtering. We can also filter by having a condition inside lock. So for example, df.lock and then df.1 greater than 1. So it returned all the rows having that condition satisfied. So as you can see here, 2 and 3 satisfies that. It's rows B and C, so we return that. This is another condition, so instead of looking at one column, we want to take a look at 2 columns. So df.2 greater than or equal to 3. In this case, it's C and D, right, based on the initial data frame. Yes, that's correct. That is what we got. We have filtered it based on that condition. Next, sorting. We can also sort items by doing the following. So we just create our series here. It contains numbers. Now we want to sort it based on, say, index. There you go. It has been sorted now based on index. So A, B, C, D, E, F, G, H. That's one way of doing it. What else? Okay, using NumPy functions on data frame. So we could perform element-wise NumPy functions like log, exponent, square root, and other functions. So we use np.random.seed to ensure that we're getting consistent values. It could be any other number, but please stick with it. So now we use the pd.dataframe code again, and then we plug in this numpy value here. This is a numpy array or numpy matrix, and it has this values that you're seeing here. So we have columns A, B, C, D. So this is our initial data frame. We could get the absolute value. That's one possible function that you could use. You could get the log, as you can see here. So log of each of the elements here, and many more. Log, xp, square root. What else? You can also read and load data using Pandas. This is a very important piece of code here. You'll often use this because you'll be dealing with tabular data set for the most part when doing data science work. In this example, I have made use of the public Titanic dataset, but it could be any other dataset. You just replace the path here. I have also provided alternatives if you want to try other dataset, such as illness toy dataset. I just use this because this is available online. And as you can see, we now have the values in the Titanic dataset. And that's it for pandas. It is a very big topic once again, and if you're not sure about certain things, I suggest that you Google it. Pretty sure there are lots of tutorials or resources out there, but for the most part, you will be needing um, these things to do your basic analysis. Thank you.